right, so let's talk about angle properties in polygons, or section 2.4 in your textbook. So 4 points it asks you to keep in mind here. First of all, it says a convex polygon has all interior angle measures less than 180 degrees. So 180 degrees is the measure of a straight line. So if you think of it that way and you think, okay, the most it can be is 180 degrees. It says a convex polygon has interior angle measures that are less than 180 degrees. And there's a picture here showing you what a convex polygon looks like. So all the interior angles, here's another example, all the interior angles of a convex polygon have less than 180 degree angles, okay? Same here, same down here, less than 180. They never cross that straight line. Conversely though, concave or non-convex will have interior angles that have gone past that 180 degree. So right here, and right there, okay? So just so you know what the word convex means. Then it says the exterior angles of a convex polygon sum or add to 360 degrees. So the outside angles. So here's a picture of a polygon, a convex polygon, and it shows you the interior angle would be on the inside, internal or interior angle. And then the external or exterior angle is the angle created by extending one of the sides. It's not the entire angle on the outside, it's just this external angle created by extending that line. So it says that the exterior angles of a convex polygon add to 360. So if you extended this picture and had the line creating all of these external angles, you could say that these 5 external angles would add to 360 degrees. And so that's a property that you might be able to use. And then it says third thing, for a convex polygon with n sides, the sum of the measures of the interior angles is 180 degrees times n minus 2, where n is the number of sides. And so remember triangles, for example, have the internal angles measuring to 180 degrees. Well, triangles will have 3 sides, so in a triangle, the n would be 3. So if we substituted here, we'd have 3 minus 2 is 1. So a 3-sided shape would have a 180 degree exterior internal angle. How about a quadrilateral or a square or a rectangle? It would have 4 sides. N equals 4. Okay. So let's take a perfect square. A perfect square would have 4 90 degree angles on the inside. So 4 times 90 is 360. So the interior angles of a square would add to 360. So have a look at our formula. If we plugged in 4 for n, we'd have 4 minus 2 is 2. 2 times 180, 360. So you can use this to calculate the interior angles of any sided shape. And then if you want that particular angle inside, all you do is take that sum and divide by how many sides there are, because however many sides there are is how many angles there are. So to get the interior angle of any sided shape, take 180 times however many sides the shape is minus 2 divided by how many. So the top part gets you the sum of all the angles and then divide by how many there are. All right, so let's, before we get going, I just thought I'd add this. You might want to pause the recording here and write this down. This isn't something that I will answer for you later on. How many sides is a heptagon, for example? This is something that you need to know, so you may want to write this down into your notes. 3-sided shapes are called triangles. 4-sided are called quadrilaterals. All squares and all rectangles are called quadrilaterals. 5-sided pentagon, 6-sided hexagon, 7-sided heptagon, 8 sides octagon, and I'm pretty sure you've heard of that one before. 9 nonagon, that one's easy to remember. 10 decagon, not so hard to remember. 12 dodecagon, that one's kind of weird. And then it says all other polygons can be named by the number of their sides. So 11-sided is an 11gon, 13 sides is 13gon, etc. And then it says if you don't know the number of sides, you call it an n-gon, where n is the number of sides. So again, you may want to copy this down, because I may ask you to find the angles of a certain sided shape. All right, so first example says determine the measure of each interior angle of a regular nonagon. So we just talked about what a nonagon is. A nonagon is a nine-sided shape. If it's a nine-sided shape, the n is 9. Determine the measure of each internal angle of a regular nonagon. So the way that you can calculate each angle is use the formula 180 times n minus 2 over n. And you're just going to substitute in n. So we'll have 180 times 9 minus 2, because n was 9, over 9. Okay, and so in your calculator, you'll take 180, you'll multiply by 7, and divide by 9. So every angle in a nonagon measures 140 degrees. Okay, next example. One of those real-life problems. Rachel is tiling her bathroom floor. She's using a regular hexagon and regular triangle tiles. The side length of a triangle tile is equal to the side length of the hexagon tile, meaning you can put them right next to each other and it will fully cover the space. Can she tile the floor without leaving any gaps between the tiles? Okay, let's talk about the word regular, because actually they've used that on purpose. If they tell you that a shape is regular, they are telling you that all the sides equal. All sides are equal. Okay, so a regular hexagon, 6-sided, 2, 3, 4, 5, 6, it would mean that every side measured exactly the same, and a regular triangle would mean it was an equilateral triangle, because that's important, okay? Because if it wasn't regular, then you wouldn't know if it fits or not, because the sides could be all over the place. All right, hexagons. So in order for it to not leave gaps, it has to cover 360 degrees, doesn't it? So when you put a hexagon, good lord, next to a triangle, it has to cover the space. There can be no gaps. So what are the angles of a hexagon? So the angles, interior angles of a hexagon, can be calculated by taking 180 times n minus 2. Well, hexagon, what's n? N would be 6. 6-sided shape. So 6 minus 2 over 6. This would be 180 times 4 over 6, which would make 120 degrees. Excuse me. So it means that in this 6-sided regular hexagon, every interior angle would add to 120 degrees. So what about this regular triangle? Well, if it's a regular triangle, every angle would be 60 degrees, and you probably already knew that. But if you didn't, we could have calculated it by taking 180 times 3 minus 2 over 3 sides. So each would be 60 degrees. So the hexagons all are 120 degrees. The triangles are all 60. Do you think we're going to be able to fit those and not leave a space? Well, there's a little picture on the next page. Have a look. And so this is an example of how you could put them up. This would be 120 degrees. This would be 120. This would be 60, and that would be 60, making 360 degrees. So it said, can she tile the floor without leaving any gaps between the tiles? You should write, yes, she can. All right, that's it.